All right, here we're going to talk about basically just general graph property concepts, domain and range, max and min, increasing and decreasing, x and y intercepts, and end behavior. So these two graphs at first I have here for you. These are called piecewise functions, which we'll be talking about in another topic later on. But then I have some other continuous type functions here that that we'll look over. And these, you get to see these later on in Algebra 2, like you'll know what they're called, but for now we're just using them to analyze some stuff on them. All right, so domain. Remember, domain is your x values, right? And range is your y values. So when you look at your graph, you want to look across, like what x values get covered. Well, if I look here, -1 is there's a graph, +1 graph. Oh, 2, there's nothing there, but it does exist here. And then 3 has an answer, 4 has an answer. It keeps going, going, going. It keeps going left and right forever. So remember, domain is left and right. So it looks like for every x value, this graph exists. So I'm going to say from -infinity to +infinity. Or you could say all real numbers, but we're usually going to write domain and range. We're going to write it with our interval notation. All right, range. So range, I have to look up and down, right? So I want to look at every y value. Well, this graph, there's nothing down here until I get to the number 5. Okay, so it exists at 5, and then there's another gap, and then it starts existing from 6 on up. So it keeps going up, 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 up. So everything from 6 up it exists for. So let's see. It exists at 5. And it also exists from 6 up. So this is going to be a little bit strange, but we're going to write this. We're going to say 5, or we're going to say it exists from 6 to infinity. So it's a little bit complicated, a little bit strange, but the y values are either 5 or everything from 6 up. Okay, so it just is what it is. All right, maximums and minimums. So this graph doesn't really have any maximums and minimums, local maximums or minimums. Local maximums or minimums are like turning points, kind of like this one has like a minimum like right here. So it's this one just doesn't have one. Something. All right, absolute max and mins. This doesn't have an either. Again, those are just like high points or low points that are surrounded by higher or lower points than themselves. All right, x-intercepts or y-intercepts. All right, so this first graph does not have cross the x-axis at all, but the y-intercept, I do see it right here at 5. So 0, 5. All right, increasing intervals. So increasing is to denote a positive slope. So look, this part right here is a positive slope. And when you do an increasing interval, when you start to increase, like you're going to say from 2 on, we're going to say. So basically using x values, you're saying, hey, from 2 over here to forever is increasing. So when we do increasing and decreasing intervals, we say, we use x values. So basically we're saying from 2 over, so 2 to infinity. And you always use parentheses, you never use brackets on increasing and decreasing. All right, decreasing. So decreasing means a negative slope. This graph doesn't have anything with a negative slope. And constant intervals, looks like this graph remains constant. A constant is where you have a flat slope, like a slope of 0, right? You're constantly at the number 5 here. You never change from 5. So this happens from everything behind 2. So from -infinity to 2. All right, end behavior. So this is just basically asking about the ends of the graph. What's going on here? What's going on here? So this means the left side as x goes to -infinity. So that means when x goes this way, what is my graph doing? And so this graph is staying at the number 5. And a lot of times it'll be positive infinity or negative infinity, but for now it's just 5. All right, and then as x goes to the right, it's talking about this. So when my x value goes to the right, my graph, what is it doing? It's going up, 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 up to positive infinity. Okay, let's look here. Domain. So if I look across at my x values, this graph exists this way the whole time. It looks like it has a problem right here, but when it stops there, it jumps up and keeps going. So we're going to say all real numbers. Now the range, that's not the case. So it looks like everything from 4 down, it exists for, but then there's a gap, and then it only is at 5. So we're going to say from negative infinity to 4, and it does include 4, so it touches 4. Ooh, and I made a mistake up here. Oh no, I'd put a bracket, sorry. So bracket on there, or it's also at 5. And it's kind of rare to have a single number like that, but whatever. A local minimum or maximum. So this would be a local maximum because it's like a high point in its area. So that's just a coordinate of negative 1, 1. That would be a maximum, right? And then this point would be a local minimum because around it is higher, and that's like a low spot. So it's local because it's not really the highest or the lowest on the graph altogether. All right, so local just means kind of like in its area. So we're going to say 0, 0. All right, an absolute minimum or maximum. So is there a point on this graph that is absolutely the highest or the lowest? This one doesn't have any. And we're going to see that a little bit on the next picture, like here. This is an absolute minimum because it's the lowest point on the whole graph. This is a local minimum because it's not the lowest point, but it is like a low point in its own area. And this is a local maximum because this graph goes up forever, but around the other points in its area, this is the highest point in that area. Okay, so it's a little bit different with each graph. All right, x-intercept looks like negative 2 and 0. So negative 2, 0 and 0, 0. Now, once you know you're crossing, you have 0, 0, it's both an x-intercept and a y-intercept. And there's no other y-intercepts. All right, increasing interval. So remember, we're looking for a positive slope. So this area is a positive slope, and this area is also rising. It's increasing. Anything that has like an increase to it, a positive slope. Okay. All right, so we're going to name those two areas. So one of them goes from negative infinity to negative 1. And then the other area goes from 0 to 2. Remember, always use x values and always use parentheses. All right, decreasing. So this little section right here between negative 2 and 0 is going down. And that's it. There's no other sections on the graph. This one's constant from 2 to infinity. And let's look at our end behavior. So this means the left side going down to negative infinity. The right side, on the other hand, is just staying constant at 5. All right. So this guy, domain and range. So this graph, as it goes up, it kind of goes to the right as well. And as this goes left, it goes up. So this graph, it doesn't look like it, but these 2 points, they're getting further and further apart. So this graph covers all the x values. So it is negative infinity to infinity for its domain. The range, on the other hand, it only goes as low as negative 6. So negative 6 to infinity, and it touches negative 6, so bracket. All right, local maxes or mins. So all 3 of these places here are local max and mins. So I will say, let's see, negative 2.5 and negative 3.5, 1 and 4, and 5 and negative 6. Now an absolute max or min, that would be this guy right here, like I talked about earlier. So 5, negative 6. It's absolutely the lowest on the whole graph. And I assume you can tell the difference between maximum and minimum. All right, x-intercepts. So we're going to have to estimate here. We'll say 3.8. So negative 3.8 and 0. Another one at negative 1 and 0. Oh, 3 and 6.4 about. And 6.4. All right, y-intercept. So it looks like it's crossing at about maybe 2.5. So notice you can have many x-intercepts, but only one y-intercept ever. All right, increasing interval. So anything that's increasing has a positive slope. So this has a positive slope to it, and then this area has a positive slope to it. So if we kind of like designate this area is positive slope, this area is positive slope, and then this part is decreasing. Okay. All right, so remember we use x values. So the increasing interval, this blue area, it lasts from here to here. So those two x values are negative 2.5 and 1. So remember, increasing intervals and decreasing intervals, these are x values. This is not a coordinate. And then this guy, it's going from 5, and then this thing keeps going to the right. So basically from 5 on, this thing is increasing. Put my little or symbol. All right, decreasing. So the pink area, this pink area right here is coming from negative infinity, and it's stopping at this x value, which is negative 2.5. Or the other part, this pink area, is in between the space, so from 1 to 5. All right, there's no constant areas. And my end behavior, look at these two things. They're both going up to positive infinity. Left side and right side. All right, last one right here. My domain, this graph looks like it goes left and right forever, no breaks or gaps. My range, it goes up forever, down forever, no breaks or gaps. All right, local min and max, that would be these 2 points here. So negative 2.5 and 2.5, and the point 3, negative 2. There are no absolute maxes or mins because this graph goes up and down forever, so it doesn't have any highs and lows that are absolutely the highest or lowest. X-intercepts, looks like 4.5. All right, looks like maybe 0.5. And 4.9. So, you know, I don't have the equation for this. I'm just kind of estimating from the picture. The y-intercept maybe looks like at about like a half. All right, increasing and decreasing. So let's label those again here. So my increasing area, remember things with positive slope. So increasing, and then this piece right here, decreasing, going down, has a negative slope. So the decreasing area interval would be in this little in-between space, so negative 2.5 to 3, because remember we're doing the x value of these spots. But everything before negative 2.5, so that would be negative infinity to negative 2.5, or everything after 3 was increasing. Constant none. And my end behavior, well, this is the left side. So look at the left side, going down to negative infinity. Right side, so look at the right side, up to positive infinity. And that is it.